Okay, this is matrix multiplication, sample C20, and what we're going to do is we're going to produce a couple of matrix products. We're going to multiply vector A by vector B, and we're going to do it two different ways. We're going to use the definition of matrix multiplication to do it first, and then we're going to use the matrix vector product. They're both very similar, they're just different ways of thinking about matrix multiplication. You can basically think about taking this matrix times the series of vectors that form matrix B, or you can think about taking the vectors that form A and multiplying them by the individual elements in B. So let's take a look at both ways. So the first one is by matrix multiplication. So this is sort of the definition of matrix multiplication. This is how you're thinking of it. You're going to take this first matrix and you're going to multiply it by the individual vectors in the second matrix. And as long as the width of this vector is the same as the height of this vector, we're in good shape. So this is what that would look like. We would have 2, -1, 2, 5, 3, -2, and we would want to first multiply that by 1, 2. Oops. 1, 2. So that would sort of be the first set of terms. It's going to give us a column of 3 numbers, which is the result of multiplying these, and that will be the first column of our solution matrix. I'll just draw a vertical bar to separate it from the next one. So we're building the matrix solution, which is the product of these, and this will be the first column. The second column then is going to be the same thing, 2, 5, -1, 3, 2, -2, except that will be times the second vector, 5, 0. So this will build the next 3 terms, and then 2, 5, -1, 3, 2, -2, and that matrix times this vector, -3, 2, and that'll build the third column, and then finally the last column is going to be 2, 5, -1, 3, 2, -2, and that will be times the last column vector for -3. And then I'll just work one of these out so that you can see it. Again, 2, 5 times 1, 2, again, you turn the row into a column and then you add the result. So it's 2 times 1 and 5 times 2, and we add the result. So it's 2 plus 10, that's 12. So that would be the first element of the top column. The middle one's -1, 3 times 1, 2, so that's -1 plus 6, and that's 5. And finally, the bottom term is 2 times 1, -2 times 2, so that's 2 minus 4, or -2. And then I'm going to repeat that with the rest of these, and this is the matrix you get. So you get 10, -5, and 10 for the second column. Third column is 4, 9, and -10. And the fourth column is -7, -13, and 14. So that's using matrix multiplication. The second way to consider this, though, is to take the individual elements here, the vectors, and sort of break them apart and multiply them as linear coefficients of this particular matrix. And we'll break them up because the 1 gets multiplied by the first column. So this would be by a technique called vector or matrix vector multiplication. So matrix vector multiplication. And here's what that looks like. So I'm going to take the 1 coefficient and multiply it by 2, -1, 2. And then I'm going to add to it plus 2 times the second column, 5, 3, -2. And so it's taking this vector and multiplying it by the 2 columns of this matrix. So it breaks it up into vectors, vector coefficients, and then vector matrix vectors. And together, this entire sum, remember it's this multiplied plus this is going to make the top row. So 1 times 2 plus 2 times 5, that's going to make the 12. So this makes the first column from the sum of these two. So there's the first column. I'll draw a vertical line. And again, that's the first column of the matrix. Now, we'll need 4 more of these. So what are the remaining 4? Well, it's just a repetition. It's going to be 5 times the first column, 2, negative 1, 2, plus 0 times the second column, 5, 3, negative 2, vertical line, and then the third, negative 3 times 2, negative 1, 2, plus 2 times the second column, 5, 3, negative 2, and then another vertical line, and finally the last one, plus 4 times the first column, 2, negative 1, 2, and last but not least, minus 3 times the second column, 5, 3, negative 2. And you'll notice that this guy makes the column 12, 5, and negative 2. And this one makes the second column 10, negative 5, 10. This one makes the third column 4, 9, negative 10. And this one makes the fourth column negative 7, negative 13, 14. So it doesn't matter whether you multiply vectors by matrix vector multiplication or by matrix multiplication. You get the same answer either way. And much of this work we do in our heads anyway, like we don't really write out all of the steps. These are only necessary to see how we get from the product AB to this final solution. But how you choose to lay it out is really up to you, and you won't really have to justify it. Just don't make mistakes with the multiplication and addition and subtraction. These things are heavily mistake prone, so getting the correct final answer here, that really requires some pretty intense concentration. So concentrate.